Academica Media. From Academica Media Studios in Miami, Florida, it's Big Ideas in Education, a weekly recap of inspiration and innovation in your schools.
Hello, education lovers. Welcome to the program. So thrilled to have you here joining us on this week's installment of Big Ideas in Education. I'm Ryan Carella from Academica Media. This week, we are happy to be joined by Tammy and Marc Goldberg, two acclaimed math education innovators and the operators of Mathnasium learning centers throughout the Northeastern United States. Our guests speak frequently on the subjects of math education and post-COVID learning, and you can find out more about our guests by checking out their Instagram at Getting Math Right. Tammy, Marc, thank you both for joining us this week.
Thank you so much. It's so good to be here.
It's great to be here, Ryan. Thanks so much.
And it's great to have a couple people who are going to help us get math right. This is an important discussion that we need to have that's only become more important post-COVID lockdown and everything that's happened there. So I'm thrilled to be chatting with you. Let me start by asking you, Tammy, to give us sort of a state of the union, a general state of affairs of where we are right now when it comes to math education post-COVID.
Oof. I'm going to be very blunt. We're in the toilet.
Wow. Okay. So no need for
we're
being
not
diplomatic
doing
here. Yeah.
well.
Let's give us the real stuff.
It's bad news. And we can't completely blame COVID learning loss for it either. We've been in the math education, supplemental math education business since 2008. We've seen all sorts of curriculum coming in with our students from private schools and public schools. And a lot of it, even pre-COVID, was very confusing, leaving kids with different sorts of issues in math, whether it's a overdependence on standard algorithms where they're not able to do mental math very well, or they're in a reform math type program where there's very little practice with computation with large numbers. And they might have a couple mental math skills, but they have a very hard time doing any kind of addition or subtraction using standard algorithms. So we had this kind of issue going into COVID. COVID magnified it, and I put a lot of blame on very confusing curriculum that teachers have to work with. It's being chosen for them that doesn't work too well.
Yeah, that tracks with most of what I've seen on the ground here in schools as well. I've often heard it said that it's a misconception that COVID created problems in education, including math education, as much as it just revealed problems and perhaps exacerbated problems that were already there. I think one place in math education, Tammy and Marc, where the data that I'm seeing tends to really show there being a big problem is in Algebra 1 specifically. I think a lot of math educators like you tend to see Algebra 1 as like this inflection point for students in terms of getting them ready for this particular subject area. It often is the first math subject where even high-performing math students can find math to start to become really challenging. And so let me ask you, Marc, what are we seeing now with Algebra 1 specifically with students? Why are so many students today unprepared for this particular subject?
I mean, one of the reasons is that we often see students being pushed into algebra too soon. And that is something that has been going on for quite some time. I mean, I think back to when I was in elementary and middle school, and the accelerated class was you'd be in algebra in 8th grade. That was accelerated. Now we're seeing that in certain schools, in some schools, that's standard for kids in 7th grade. And you have kids that are being put into, geometry in 8th grade or algebra 2 in 8th grade. And, there are certain kids that are ready for that. But I'd say most are not ready for algebra when they get there. Okay. So what's the reason for that? Some is too soon. A lot of it is because the state of elementary math education, as Tammy was saying before, is not very good. So math is cumulative, right? It builds on itself.
Yeah.
And so, for example, if we have trouble with number facts, if we have trouble with multiplying and dividing, if we don't have a good working knowledge of fractions, it's going to be very, very difficult for us to have success in algebra. If we have trouble adding and subtracting, well, how are we going to add and subtract integers? So this is, I think, a direct result of students just being unprepared. And a lot of that comes back to just curricula in the school systems that do not support the kids well, do not necessarily have a good handle on what is really necessary to get them to that point of having success in algebra and beyond.
Well, to the extent that we find curriculum to be one of the culprits here, Marc, why is that becoming a problem now? I mean, we've always had math curriculum for, when I was in math, we had curriculum that we were exposed to, and my parents had curriculum that they were exposed to. Has the curriculum changed with this latest generation, and that's the problem, or is something else happening to the curriculum that's creating these gaps that we're seeing?
Well, it's been changing for quite some time, and we like to think about it as like kind of these two schools of thought, right? There's the traditional math, where math was mostly about memorization and algorithms and formulas, and then you have the flip side of that, which is math is about discovery and just exposing kids to different ways of thinking and that hoping that they can figure it out.
Let's throw out the rules and let's let the kids discover what the rules are for themselves.
Right. And
that's
right, focusing on
reform
number sense, right? That we need to understand what's going on. And the problem is that from what we've seen, there's very few curricula out there for schools that do a good job of marrying those two ideas together.
Because in the 80s, talk about what the curriculum was like in the 80s.
Well, that was like
when we went
to school, right? It was
very
traditional.
Traditional, and guess what? It worked pretty darn well.
It did. Although me, somebody who was relatively well mathematically inclined, when I had to multiply a number by 12, I would see the algorithm in my head, right? Like I would line up the numbers and I would do the algorithm. I didn't think about things like, oh, I can multiply, for 12 times 7, I can think, well, I can multiply 10 times 7, 70, and 2 times 7, 14, and put it together to make 84, right? I wasn't taught to think that way, and I wasn't naturally wired to think that way. I would have greatly benefited from somebody teaching me to think that way. But I also need to be able to, as the numbers get bigger, be able to line up, 372 times 27 and be able to effectively solve that problem efficiently. And I was taught to do that, right? I was taught to do that efficiently, but I lacked strong mental math skills.
And that was the one problem with the curriculum in the 80s, is they didn't have a strong mental math supplement, so that, like Marc was saying, 12 times 12, he might line it up and use an algorithm, or like 12 times 13, he just might say, I didn't learn that one, I don't know how to do it.
Yeah, and that's what we see.
Or I have to go and use
in certain cases.
So at the risk of oversimplifying it, Tammy, is when you say that there's an issue with the curriculum, as you're both stating here, is perhaps the issue that we're seeing an overcorrection to the problems of the 80s in math curriculum? Because I think, and again, I'm you guys are the experts here, but from what I've heard from math experts in the past is that one of the flaws of that 80s style of math that you all and I learned was that maybe it was a little too over-reliant on memorization and formulas, where, when you learn how to do long division, for example, you learn the process and the procedure and how to make the numbers carry over, but nobody actually explains to the students what it means when you move those numbers. And so when you get to the more complicated math, you don't have the reasoning skills required. And so the modern instruction in math is supposed to be the correction of that, where we're relying less on kind of the rote formulas and processes and more on kind of creating this number sense and reasoning. But maybe what you're saying here is that we've gone a little too far in the other direction, and now we need to go back and learn a little bit more formula and process again?
You just identified the problem so well. And I think that's wonderful.
Right.
And I think there's an awareness of the problem. It's just the solutions that have been proposed haven't quite worked, obviously.
Right.
Like look at our math scores.
Right.
Right. So what Mathnasium has figured out is what is the proper blend?
Yeah. What's that balance?
What was wonderful from traditional 80s math? And what did it actually need what spices did it actually need to make it amazing, to make it taste amazing, to make kids love it, to make kids be able to compute so well and to love math.
Well, to really understand what's going on.
And to know when to use an algorithm or a calculator and when to just do it in their head. To not get a problem 101 minus 99 and need to use an algorithm for it. To know that that's a great problem to use your mental math skills. And let's think, how far is it from 99 to 101?
Mm-hmm.
Right.
Tammy, let me get your perspective on another area that I know is a hot button issue for a lot of the viewers and listeners here, and that's parental support when it comes to math. You don't have to be math experts like you two are to know that, like, parents find themselves frustrated when it comes to helping their kids with their math homework. Part of it is because they often learn math a different way than kids are being taught today, and so that leads to a lot of arguments and fights around the dinner table when homework time rolls around. But a lot of it's just because, like, a lot of parents have their own math anxieties that they are now having to relive when helping teach their kids this stuff. And so a lot of parents want to be there. They want to support their kids. They are on the front lines of this math crisis we're facing now in education. Can you talk to those parents for us right now? We'll start with you on this, Tammy. Do you have any advice for these parents on helping them navigate this very difficult time right now?
Yes. I would say, parents, it makes sense that you're frustrated. It makes sense. If you're being told that the curriculum is actually in the child's best interest and that they should be learning in these confusing ways, you're being gaslit. That's incorrect. Your instincts are right. So that's number one. Number two is, do not rely on your child's school to get math right. At this point in history, now more than ever, you need supplemental help. And it would be really great if you could get a third-party assessment of your child's math skill that is not through the school. Unless you have a school who you really believe has your child's best interest, your child, not just like the collective. Like, this is about taking personal responsibility for your child in this situation. Like, don't leave your child's welfare in this current climate up to the school system. And I would seek a Mathnasium learning center, because this is what we have sunk our professional lives into, is to figuring out how to get math right. And it all starts with an assessment that really gets to the heart of your child's issue and what is the root of the problem. And often the root is number facts, multiplication facts often. Sometimes it goes back further.
Number facts? Pardon my ignorance.
Sure. The times tables.
Right. And addition, subtraction, multiplication, division, the most commonly,
0 plus 0 through 12 plus 12. Right. And same for division and multiplication.
Right.
Whether we like it or not, right? There's just, perhaps it's an unpleasant fact, but it's an important one, is that even though, like, number sense and math reasoning skills are important things to teach, and maybe we weren't teaching it well enough in the 80s, at some point there's just stuff you have to memorize. You got to memorize the times table.
So I'm gonna push back on that.
Oh yeah,
because there is a way to get there where the facts are committed to memory, but you do not have to sit there and memorize a series of digits. So a great example.
There's a way to commit things to memory without memorizing. All right,
correct.
I'm following you on this.
Okay.
I'm excited. Let's hear it.
So let's take multiplication facts, for example. So, like, there may be certain facts that we have to get to the point where we just really know it, and maybe certain ones we drill, like fives, for example, right? The fives facts. But most kids are familiar with that because they've been counting by five since the time that they were. So a lot of them in kindergarten, some even younger than that, right? So most kids, when they come to us that are having difficulty with multiplication facts, most of them are comfortable with zeros, ones, twos, fives, and tens. Most of them are pretty fluent there, right? It's the others that we have trouble with. And so we can leverage the prerequisite knowledge that those kids have and teach them specific ways of thinking that are number sense techniques to figure it out. And the more that they do that, it becomes committed to memory. It becomes second nature. but we didn't sit there with a flashcard. So I'll give you an example. So let's say something like 7 times 4, for example. So for the fours facts, we teach kids, well, for anytime we take a number 2 times, we can double it to find a number 4 times. So if I know 7 2 times is 14, I can double 14. And I can double 14 because I can double 10, 20, double 4, 8, and put that together to make 28. So there's one example. Now we can then extend that out as we get more comfortable. Now, once we have our fours, well, we can find 7 8 times. We can think, well, I know 7 4 times is 28, and I can double 7 4 times to get 7 8 times. 28 doubled. 20 doubled is 40. 8 doubled is 16. 40 plus 16 is 56. So there's one example. Another example would be leveraging our 5 times. So let's say 8 times 7 as a good example, right? Which means 8 7 times. That's how we speak about it in Mathnasium. Yeah. That 8 times 7 means 8 7 times. It doesn't mean 7 groups of 8 or 8 groups of 7. We say 7 8 times.
It can also mean that.
That makes so much more sense,
doesn't it?
Yes.
Yes. It doesn't mean that it doesn't actually.
8, what does that mean?
Right. It's yes. There's a cognitive dissonance there, and so but when it comes to mastering our multiplication facts, thinking about it as 8 7 times is much more useful. So if I know 8 5 times is 40, so I can ask a child, well, so I can say 8 7 times is 8 5 times, and how many more 8s? 2 more 8s. 2 more 8s, yeah. So I have 8 5 times is 40. 2 more 8s is 16. 40 plus 16 is 56. Now, the more that I do that, the more that I engage in that way of thinking, the more that I have visuals that, structures that support my learning of that way of thinking, it becomes second nature, it becomes committed to my memory. So not only did I get the desired outcome, but the process of getting there helped build my number sense, and it was not painful.
And you become more fluent. I mean, maybe that's a better word than saying committed to memory. It's a fluency. We're building a fluency. And think about that. The kid who was just forced to memorize 8 times 7 is 56, missed out on all of that great mental math exercise in order to get there. And I feel like this is a really good example of what I'm talking about, where Mathnasiums have figured out, how do we solve this problem of, we've got kids just memorizing facts in the 80s, and it's still happening. That's
right, because they right, because reform math doesn't have a solution for this.
Right. So building in some great mental math into that process so that they can use that when the numbers get bigger. We would have missed out on that opportunity if we were just flashcards, just memorizing.
Right. Also,
plus it's stressful. And parents don't want to do it.
Right. It's stressful. And also when we get to division, when we've gone through this process of figuring out the facts, we understand that relative size. It's a lot easier to transfer that over to division facts when we've thought about it in this way, right? So that, 56 divided by 8. Oh, well, I know 8 5 times is 40. So, that's right. I need 2 more 8s. That's 7. Right.
How many of these
are there inside of that?
How many 8s are there in 56?
Right. Because I've had that inverse of, this number this many times. Well, that's all I'm doing is fitting that inside of this other number. And so I've got similar tools that I can use to get there with division if it doesn't come to me like that. Right. Ultimately, what we want are for the facts to be there like this, but they're not always going to be at our disposal. So we need to have a structured way of figuring it out. And this is where school generally has gotten it wrong. A lot of the reform programs is that they are so afraid of directly teaching kids efficient ways to solve problems. And that's what
choosing like two methods, like choosing like 2 or 3 methods that we're going to focus on and we're going to practice that. It's kind of against the code of reform math. They would rather expose them to like 10 different methods and let them choose which one they'd like to use. And we've seen these kids coming in doing our assessments and
they're paralyzed because they don't know what to do.
They can't compute with large numbers because they haven't practiced 1 or 2 ways really well.
Right.
Wow. That's definitely a troubling component. And, When you say that the fault largely lies with curriculum, like I don't heap that blame largely upon schools, right? Schools are
No.
often have their curriculum dictated to them by districts or by textbook companies, curriculum providers, things like that. Teachers often have to follow like a certain set of procedures or a certain script. And so is the reform that has to happen merely at the school level, or are there like folks above the school level where we really need to see this reform happen if it's a curriculum issue?
Oof, good question. It's big textbook, whatever that is.
Yeah. But the one thing that I will say that I think is important that we have in our Mathnasium centers and just with Mathnasium in general is we have the opportunity to work with each child exactly where they are and propel them forward from that point. In school, it is very, very difficult to deliver on that in the same way because we're in small group and one-on-one settings. And when I say small group, it's not that each child's working on the same skills. It's an instructor that's balancing time, working with multiple children.
Right.
And
so there's always that disadvantage.
There's
you're
right.
saying a classroom structure will have, but there's like ed tech companies trying to solve that.
Right.
But they don't have our curriculum.
Right. And when you take the human element out of it, especially for children, it's like, you need that human interaction,
especially for the elementary.
Oh,
age
yes,
Yeah.
but for sure. So I do think it's important to note that, yes, I think we could have better curriculum that brings in the point that we're making, which is that there needs to be a better blend, that we shouldn't be rejecting traditional math, but we should be looking at as, hey, there are key skills that were traditionally taught years ago that kids do need. And by the way, we can bring transparency to why they work, and we can help kids to develop number sense so that when they look at a problem, they can look at it and say, do I have an efficient mental math way to solve this? I can inspect it and come up with a solution fairly quickly. If not, I can pull out a procedure that I've mastered that I know is reliable, and I can get that answer. And so I think conceptually, if we had curriculum that was designed through that lens, would we be inherently so much better off, regardless of the individual
customization?
Exactly, the customization. Yes, we would.
But
would that get us 100% of the way there? No, but I think it would help dramatically.
Tammy and Marc, I really appreciate the hard truths that you're giving here, right? This is a significant crisis that we're having in math education, and certainly across the board in education, in particular post-COVID, but math is a uniquely challenging issue. It's a big problem, and the first step to solving it is being honest about what the problem is, not sugarcoating it, and coming forward with some bold solutions. And I feel like that's what we've done a lot of on this discussion, and I really appreciate it. I encourage our viewers and listeners to check out our guests on Instagram at Getting Math Right, and certainly check out Mathnasium and see if that's the right fit for your kid. Definitely can see the merit in third-party solutions to help supplement what's happening in a student's school. Tammy, Marc, before we let you go, I want to ask you each one final question. We'll start with you, Tammy. If with the snap of your fingers, you could make one change to the education system, what change would it be?
It would be a fact fluency program that every child receives that is amazing and that actually works. The children love it. The teachers love teaching it. And the parents are happy because their kids are successful, and the kids are happy, and everybody's happy because they've got a program that really works, which sets them up extremely well to move forward into that algebra. And then I'm adding something. Why don't you pick up with that? I want Algebra 1 to have like high success rates. And I think that it begins with number fact fluency. So number fact fluency program for all that works.
And those are both great answers. I'm not sure how you're going to follow that, Marc.
So I'm actually, this isn't one thing, but I'm going to say, yes, that is absolutely essential. But if I need to pick something different, I would say that we do a much better, that if I just snap my fingers, that every child, as they approach pre-algebra, has a strong understanding of the 0 to 1 interval, that they have a working knowledge of fractions.
Oh, okay.
That is, so it's that combination of what Tammy said with number facts and a strong working knowledge of fractions.
That will lead
That would lead to
Algebra
success
1.
in Algebra
Success.
1. Yes.
I like it.
Really appreciate both of your perspectives here. I've really enjoyed this discussion. And I feel like there's so much more we could talk about because I want to talk to you about like math self-concept, positive mindset, growth mindset. We didn't even get into like the psychology of math education. And so I'd love to bring you back real soon and keep this conversation, this very important conversation going.
Yeah, we'd love to.
That would be awesome. Absolutely.
Fabulous. Tammy, Marc, thank you both so much for joining us this week.
You're welcome. Thank you.
Thanks for having us, Ryan.
And thank you all for checking out Big Ideas in Education.
The views expressed on the preceding program have been those of the hosts and guests and do not necessarily reflect the views of Academica, its clients, staff, affiliates, or advertisers.